All right, let's go over this problem. This is skills practice, page 100, question B8. I'm just going to read the directions. The directions tell us determine whether the graph of each rational function has a vertical asymptote, a removable discontinuity, both or neither. List the discontinuities if they exist. All right, so what I need to do, let me write down the problem. F of x equals x squared plus 2 over x to the fourth plus 2x squared. So we've been working with rational functions. Just a quick review of rational functions. Rational functions are just fractions. And in finding these, first thing you want to do is see if we can factor this. So if I try to factor this denominator here, I get x squared plus 2. And then if I look at the bottom here, you could try to use Xbox method of factoring. There's an A, there's a B, there's a C. And remember, you can only do this Xbox factoring if it's a trinomial, so you can put plus 0, and then half of this value 4 is 2. But I'm going to see if I can take out the greatest common factor. My greatest common factor, I recognize that this has an x squared, my GCF. Then I'm left with x squared plus 2. Now, if you need to, in rational functions, if you just set your parentheses around these, okay, what we cancel now, cancel is equal to our removable whole. So if I do this, if you one expression over the other, that means I'm going to have as my removable whole x squared plus 2 is not equal to 0. Now, I wrote that 1 there because a lot of times students will cross this off and they think they're left with just x squared, and that'd be incorrect. You actually have a 1 there, so you're left with 1 over x squared. Let's go ahead and solve this removable whole. I want to solve for x here, and again, pretend the equal sign is just like a equal sign, so I'm going to subtract 2. I'm left with x squared not equal to negative 2. If I take the square root of both sides, let's see if this will show up. Remember, you're left here with just x is not equal to plus or minus. Remember, anytime you take the square root of an equation, it becomes plus or minus. And then I'm going to write out the factors of negative 2. The factors are negative 1 times 2. And we've been learning for this past year, the square root of negative 1 equals I. So your answer is x is not equal to plus or minus I radical 2. Now, remember, I means imaginary numbers. That is a complex solution, so that's actually not going to be on the coordinate plane system. So basically it means that there is no removable whole. See if I can double box that. The reason why there is no removable whole is because they're telling us on the complex there's an answer, but our reals with x's and y's, there is none, so there's no removable whole. Okay, the next thing I'm going to do is I'm going to get a vertical asymptote. Now the vertical asymptote is taking the denominator after what you've canceled and setting it not equal to 0. So vertical asymptote, set denominator not equal to 0. So all I'm going to do here is take x squared and set it not equal to 0. To get rid of the exponent, you're going to do its opposite. So you're going to get x. Now we would not say positive or negative 0. Two identical numbers that multiplied equals 0, that's 0. So I have x is not equal to 0. Do that in pink. So that's how you would find your vertical asymptote. So now let's go ahead and do the horizontal asymptote. All right, what you're going to do here, now it doesn't matter, you're going to compare the exponents. So if you compare the exponents, I have a 2 and a 4, or you can go down here and do this one. And you'll notice it's the same, 2 to 4 or 0 to 2. So I'm going to write both of them. You'll see that it's the same, 2 to 4. Remember, this represents the top, and this one is the bottom. You have to put an inequality in there, and 0 is smaller or less than 4. And then if you get your formula sheet, let me pull that up online. All right, on our chart, we wrote that anytime it's a less than, you will always have a horizontal asymptote at y equals 0. So let me go ahead and double check our instructions. Determine whether the graph of the rational function has a vertical asymptote. It has one. A removable discontinuity or removable hole. We talked about a donut hole. It does not. And then it says list the discontinuities if it has one. So we've listed it, and that's pretty much all you had to do. Let me just draw a quick graph so you can kind of see what's happening to this graph. So here's my x, here's my y. This vertical asymptote is here. And this one's going in this direction. And remember, this is an even. Evens are split. Odds are the volcanoes. So this is split. And I believe, if you forget, like I am forgetting right now, you can just make a table of values. And I'm just going to pick the one value to the left. And I just want to know if it's above or below. So just -1. -1 squared is -1 times -1 is 1. 1 divided by 1 is 1. So you'll notice that my graph is actually above. So this is where my graph's going to look like. So you don't need to graph it on this problem, but I'm just going over it as a quick visual. And again, there was no removable hole. There's no value where my pencil represents the x values and it stops on that graph, and then that would be undefined, which is a donut hole, which we don't have that one. All right, I'm going to go ahead and stop this problem, and then if you exit out back to my YouTube channel, I'll go back and I'm going to do a couple more problems. See you later.